Hello everyone. In this video, I'm going to introduce you to the concept of trusses. I have always considered trusses to be one of the intriguing and towering achievements in structural engineering for the following reason. Look at this particular truss structure. At the first sight, you can immediately see that it is made up of two members. I can call this as member 1 and this is member 2. Now, what do you think is going to happen when it is subjected to forces? At the first sight, we are tempted to think that, okay, member 1 is going to bend and member 2 may bend. But that's not what happens. Trusses will never bend because they are made up of pin joints. But that is not an enough explanation. Let me tell you why trusses would not actually bend in quite an intuitive manner, but I'm going to use the power of mathematics here. Okay, so I will just consider member 1 now. Member 2, I'm going to consider member 2. I'm going to decompose the structure. First, let me consider member 2. It is subjected to a force of magnitude capital P. This force, capital P, can be resolved into two components. So I will call this component, let us say that this angle is theta, as capital P cos theta. I'm just resolving the forces. And I will call the vertical component as capital P sin theta. Now I'm going to analyze what I have done. I have decomposed the structure. I have considered member 2 alone, and member 2 is subjected to a force of magnitude capital P. I resolve the forces into two components. This component, the horizontal one, is called as capital P cos theta, and the vertical component is capital P sin theta. What is the effect of capital P cos theta in member 2? Capital P cos theta causes member 2 tension, which means that the type of force that acts on member 2 because of capital P cos theta, member 2 will be subjected to tension. And what is the effect of capital P sin theta to member 2? Capital P sin theta tries to rotate the member. It only tries, it only attempts. It tries to rotate member 2. But actually the rotation is not happening because the rotation of member 2 will be prevented by member 1. You see, member 1 is here. This is member 1. The rotation of member 2 in this direction because of the vertical component capital P sin theta is prevented by member 1. Okay, so as a result, the capital P sin theta, that force is transmitted to member 1. Okay, so let me explain that here. This is our member 1 that is subjected to capital P sin theta. I will call that as P1 for simplicity. That's right, where P1 is capital P sin theta. And I will now call this a new included angle theta 1. Now I can resolve this force into two components. One is the horizontal one, which is capital P1 cos theta, and the vertical one, which is capital P1 sin theta. And what is the effect of capital P1 cos theta? Obviously, it is quite obvious that it will be subjected to compression. So member 1 will be subjected to compressive stresses. And what is the effect of capital P1 sin theta on member 1? Well, capital P1 sin theta, this force tries to rotate. Only tries. It just attempts to rotate. This is tries to rotate. But the member 1 is not going to rotate very well because the rotation of this force, when it tries to rotate this force, that is prevented by member 2 here. So this is our member 2. So I will call this as P2. Now P2, when it tries to rotate member 1, will be transmitted to member 2. All right, will be transmitted to member 2. So this force P2, when it is transmitted to member 2, this force P2, when it is transmitted to member 2, like this. This is P2. Again, you can resolve it into two components. One is the horizontal component, which is going to be P2. The angle is going to be the same. It's theta. It's going to be P2 cos theta. And the vertical component is going to be P2 sin theta. Now, what do you think is the horizontal component going to do? Well, it produces tension. So which means that on top of this tension, which is already there, you're going to add this to this tension. And what do you think is going to happen to P2 sin theta? I will call this as P3. It tries to rotate member 2, but the rotation is prevented by member 1, which is present here. So again, so P2 sin theta, which is now called as P3, will be transmitted to member 1. So again, you know where the story is heading. Again, this is subjected to P3 is acting in this direction. The included angle now is theta 1. So it is again resolved into two components. One is the vertical one, which is P3 sin theta 1, which you can call that as P4. And the horizontal one is going to compress member 1, which is going to be P3 cos theta 1. Okay, so you keep doing this. So finally, you will be able to understand that member 1 is always subjected to compression, and member 2 is always subjected to tension. So every time you keep resolving the forces, you started with capital P and you resolve the forces, you ended up with P1, one component that tries to rotate, that is P1. And then P1 is transmitted to the other member and produces either tension or compression, and then the one that tries to rotate, you call that as P2, and the next one that tries to rotate is P3. So every time you resolve the forces, one of the forces is trying to rotate to one of the members, and that rotation is prevented by the other member. Okay, so the rotation of member 1 is prevented by member 2, and the rotation of member 2 is prevented by member 1. So you keep resolving the forces. So all these forces are getting smaller and smaller until you reach 0. So you do this sufficient number of times. At one point of time, the force is going to become infinitesimally small. It tends to reach 0. At that time, all the forces are completely resolved. So there will be no more forces to resolve because the force value becomes infinitesimally small. For all practicable purposes, we ignore it without incurring any serious error in mathematics. Okay. So the net result is that member 1 will be subjected to compression and member 2 will be subject to tension. Okay. So this is a slightly different way of looking at the trusses, but usually it's not explained in this manner, but it helps us to understand, it helps us really to understand how the member 1 prevents the rotation of member 2 and how member 2 prevents the rotation of member 1, and as a consequence of one member trying to prevent the rotation of the other member, here exactly as a consequence of member 1 trying to prevent the rotation of member 2, it is subjected to compression, and the consequence of member 2 trying to prevent the rotation of member 1, it is subjected to tension. So this is a short introduction to the concept of trusses, but if you want to solve the problems, you have to take the moment of all the forces about a particular point. You can equate the upward force to the downward force. You can solve the problems. But this video is purely to explain the concept of trusses and how it is not subjected to any bending stresses. That is amazing. Okay, in the next video, I'm going to derive the stiffness matrix for a truss member. So we will build the concepts. So this is just a basic understanding to the concept of trusses. Thank you so much for your patience.